This is the second video for November 3rd and November 4th. What are we doing? Factoring trigonometric expressions and using those to simplify. So we did the first two in the first video. I'm gonna go through. I'm gonna, make a line here. Go through and do these next two, maybe one on the back for this second video. All right. So we were looking at this expression. We're trying to factor it, but we notice we have a quantity squared. That quantity being cotangent. Minus 12, that quantity again, and then that quantity doesn't appear. We could rewrite this as like y squared minus 12y plus 35 if we wanted to. And now hopefully this is a form that is familiar. Hopefully we can see that we can factor this by figuring out what two numbers multiply to give us this value, that add to give us this value. Or in other words, we could say like product. We need a product, or two numbers that multiply to give us 35, and those same two numbers need to add or give us a sum of negative 12. Well, as of right, what we can do with this, what we can do is say this is negative 7, negative 5. Negative 7 times negative 5 gives us positive 35. If you were to add those two numbers together, you get negative 12. So that works. And so this factorization becomes y minus 7 times y minus 5. But ultimately we know that y is cotangent. So you say this is cotangent of x minus 7, cotangent of x minus 5. All right. So we're factoring that. We're going to need to use that. The reason we're going over that is because we're going to need to be able to use that in upcoming lessons after this upcoming assessment. And then we have this problem. What we really need to be careful with here is we need to recognize we have cosecant squared minus 9. But we know that 9 is a perfect square. We can rewrite 9 as 3 squared, if you will. And so because of that, this is a difference of two squares, similar to what we had here. And so we can write this as cosecant of x, this quantity being squared, minus the quantity being squared here is 3, times cosecant of x, again, this quantity being squared, plus 3, all over cosecant of x plus 3. No, we have, if it helps you to put this in parentheses, we have a quantity in our numerator and denominator. This quantity divided by that quantity is 1. And so we're left with cosecant of x minus 3. All right, so these are simple things that we can use potentially to simplify expressions. Here we're factoring trig expressions. Here we notice that we have a quantity in our numerator and denominator. Really the same quantity divided by itself, which is 1. 1 times cosecant minus 3 is just cosecant minus 3. Again, if you need to pause it, ask questions, please do so. I'm going to go ahead and flip to the back side. Okay. Let's go over the first one. So, chances are I'll probably do 2 more videos and then stop there. But here we notice that we're adding fractions. We're adding these two fractions, and in order to add fractions we need a common denominator. Here we do not similar, but not actually the same. Now what we're going to do is create our common denominator. It would be great if we could make this, put this in this denominator, that and that denominator. And we can. What we're going to do is, I'm going to write it down here, 1 minus sine x plus 1 plus sine x, 1 over 1 plus sine x. I'm going to give this denominator 1 plus sine x. So I'm going to multiply over here by 1 plus sine x. But I can't just do that. If I multiply the denominator, I have to multiply by the numerator as well, because ultimately this is just 1. It's not changing the value of the expression. Do a similar thing here. I'm going to give this denominator 1 minus sine x. Now let's see what happens. In our new numerator over here, we would have 1 plus sine x. Our denominator becomes 1 plus sine x times 1 minus sine x, plus our new numerator over here becomes 1 minus sine x. Denominator becomes 1 plus sine x times 1 minus sine x. Now what's going to be tempting is to divide these two out. Divide that, divide that. But if we did that, if we divided those out, we would end up back here. So what we can do, now that we have a common denominator, we can go ahead and add our numerators. And really, if you think about it, 1 plus 1 would give us 2 in our numerator. I'm going to do that over here. Positive sign plus negative sign, those would actually go away. So in our numerator, we're left with 2. When we add fractions with the common denominator, that denominator does not change. Okay. Now, in class, we actually stopped here. I'm going to keep going because this can actually further simplify. And the way this further simplifies is now we can't really do anything in this form, but let's go ahead and multiply our denominator using FOIL. So, quote unquote FOIL. 1 times 1 would give us 1. 1 times negative sine would give us negative sine x. Sine x times 1 would give us positive sine x. Positive sine times negative sine would give us negative sine squared x. We can see that these two, negative sine plus sine, really those go away. So we're left with 2 over 1 minus sine squared x. And then we see 1 and sine squared in our denominator. Anytime we see 1, sine squared, cosine squared, any combination of those three, we should automatically, this is what needs to get there. We should automatically look at this Pythagorean identity and see if we can change it to make it this. Well, I have 1 positive, which is what I want there. Sine's positive here. If I subtract on both sides, then that would make it negative on the same side as positive 1. So we're left with cosine squared equals 1 minus sine squared. Now we have what we want. We have 1 minus sine squared here. It's equal or the same as cosine squared. Because of this, because these are equal, we have equality. This is the same thing as 2 over cosine squared x. Because these two are the same, I can replace 1 minus sine squared with cosine squared. And then with your identities, the reciprocal of cosine is secant, so we could rewrite this as 2 secant squared x. Okay. So that's a good strategy to use to simplify these expressions. Chances are I'll probably do one more video, possibly a fourth, and explain at least these two problems. If you have questions, email me, contact me, and hopefully I can get back to you soon.